Okay, welcome everyone. This is Group 5 presenting our robotics team crisis. That is the scenario that we have chosen to present on this week. So, a slight introduction. What's the scenario we want to look at? And we have decided a robotics team that had 6 months to create a robot for competition, including the hardware and the software necessary. So, unfortunately, they ran into some issues along the way. Um, for example, the teams were separated by hardware and software. And in the IT development world, hardware and software should coexist and they should be equal because sometimes the software is going to have particular hardware requirements, and these two groups need to cooperate one with another. They need to have communication, and in this particular example, communication was non-existent. Changes by each team alters specifications, and when there's no communication, you have no idea what changes you need to make on your side, and thus the project was not completed as expected. So let's take a look at some of the ways that this scenario could have changed. So let's take a look at how the project could have been completed. Now, one thing that we have learned is to develop a culture of imagination, risk-taking, high trust, and a scientific approach. So think of a child who's building a castle with wooden blocks. They are willing to try anything that will make it a perfect castle, including using other things um, that are not wooden blocks, like your china in your kitchen, or they're going to tear the house apart to do whatever it takes to get that castle to work. So a culture of imagination, risk-taking, high trust, and a scientific approach between the hardware and the software groups would have made this project go a lot smoother. Another thing that we have learned that this group could have implemented is to get together and plan out how things are going to be done, such as creating a value stream map or a visual progress bar of each feature or specification. So think of your own home, your own family. When you give your kids chores, you could make them a checklist. Do this, and do this, and then you're done. And when you're done, you get rewarded with ice cream, or you get rewarded with extra playtime. Um, Feedback is a great tool, but also having a visual representation of your project will make it easier to see where your team needs to make improvements. Another thing we've learned about is to have smart team boundaries. So when they split this up between hardware and software, the team sizes should be kept small, and Conway's law should be implemented. So we should split teams by function or by architectural layer. So there could be some overlapping between guys who specialize in hardware and software, but also let's have some teams that are loosely coupled and independently productive. So maybe we have a few who specialize in both areas, and they will be able to coexist and help the rest of the group. And we should focus on essential work. So we implement a lean approach to eliminate waste in the process. So if communication exists and the hardware and the software groups are very efficient at multitasking, waiting, let's eliminate unnecessary handoffs and needless manual labor. And let's not try to go for any heroics. Let's stick to the basis of the project that we're trying to complete so that we don't waste labor. And the andon cord is something that could have been implemented in this particular scenario as well. So when something goes unexpectedly wrong, it needs to be fixed as soon as possible. So the hardware and the software groups would need to stop what they're doing to swarm the issue that's holding their progress back. Now, this provides a safe environment to deal with issues as they arise, even if the issue occurs in the hardware department. The software department will need to know so that they will need to make changes if they need to, and it serves as a form of feedback so we can learn from mistakes to get better and more efficient. Another thing that these groups could have implemented to make the project go more smoothly would be to test often, daily and weekly, create a fast feedback loop. We need to use automation for building and testing processes and ensure that the automated processes run in a dedicated environment. Now, testing often ensures quality. So on average, 50% of code is changed each month. So we need to test often to make sure it still works. In conclusion, we as a group, we wanted to focus on how feedback and consistent communication would have made this project go smoothly between the hardware and the software groups. Implementing these concepts would have made the progress not only go smoother, but the team would have learned more along their way, and perhaps they could have moved on to more challenging projects. So think of children playing the popular hot or cold game. Know that to perform well, people need to know and people need to be told how they're doing. So if you're looking for an object, people in the room yell out, "You're cold." Now you're getting warmer. Oops, you're cold again, but now you're hot. So without that constant, consistent feedback between groups, the hardware and the software groups are basically walking blind. And at best, they'll accidentally reach their goal or they'll wander aimlessly, but they never reach the final destination. So we need to work as a team with smart boundaries, and we need to have automated, thorough testing. And that concludes our presentation of some issues that the robotics team encountered and some general DevOps implementations that could have made the process go a lot smoother.